Hello guys, welcome back. I'm Koneru Suhas and we are going to be discussing the same chapter, force and pressure. This is part 3. So in last two classes we have finished force and we have also finished examples of pressure. So we were in liquid pressure, in which we have done the first example, that is we have discussed that liquids exert pressure in all four directions, that is upward, downward, sidewards. So here in the third example we have seen that how liquids exert pressure in the bottom, in the bottom direction. So now let's discuss activity 4, that is liquid also exerts pressure sideways on the walls of the container. So for this you have to take a container, but this time it should be closed on the bottom. It should have a spout like this, and you put a balloon like this here. Fill it up with water. It should be more than this or it will not inflate the balloon. So now this balloon will start expanding. Why? Because liquid also exerts sideways pressure. Pour some water into the tube, you will notice the balloon bulges out. This shows that the liquid also exerts pressure in the walls of the container. So now liquid exerts pressure in all four directions. What you can do is take a balloon, fill it up with water. It should be like this, a water balloon. Then beforehand only pin some holes. If the holes are there here, here, then you can see after filling up with water, the balloon will start giving out water in all directions which you have pinned the holes. This is the example of balloon containing water, and balloon exerts pressure in all directions. So the next one is factors affecting the liquid pressure. The pressure at a point in a liquid depends on the following two factors. The height of the liquid column. Liquid pressure increases, the density of a liquid. And the other one is, first one we will discuss, liquid pressure increases with height of the liquid column. This can be demonstrated by the following activities. So you take the same open tubes, you can fill it up like this, open tubes, take a balloon, first one fill it up for like a quarter, you fill it up, and the second one you fill it more than half. It will bulge more than the first one because here water level is higher. The liquid column the height of the liquid column is higher, so it bulges more. Okay, so we have seen this. Next one is density of the liquid. Density. For this you can take same two tubes, you can take, open on both sides, balloon. Okay, balloon. Wait, I'll just do it again. It was not that good. Okay, take this, put a balloon here, open on both ends, take the same cylinder, put a balloon over here. Okay, now pour concentrated sugar solution. And here just normal water. So what? Concentrated sugar solution. You tell me which density is higher, the water or the sugar solution? The sugar solution will be higher, the concentration will be higher, so density will be higher. So the more density, if you fill it up like this until here, same, you have filled it same, you filled it up same length. So what will happen? This will bulge slightly more than this. You see slightly more, like here. See, slightly more it bulges because the density of the balloon increases more because in the increase of the density of the liquid. Now we will go to consequences of liquid pressure. The thickness of the walls of the dam is increased towards the bottom. So I'll show you this with the help of the diagram. Okay. So take like this. Here there is water. In ICSE textbook, I am referring to the ICSE textbook, physics class 8th. So now this is the water. It exerts pressure like this. It will go up. The lower you go, the higher the pressure will be. Then this is the dam water reservoir, and now this is the wall. It is like this. Okay. So now it is like somewhat like this. Okay. So now here you can see, here less pressure is exerted. You can see here it's going up. The bottom you go, the more it will be. So this is the reservoir. The water is putting effect on this wall. So you can see here also it is going in the increasing pattern. The lower it goes, the wall is becoming higher. You can see here it is more. Here also it is becoming higher because the pressure is increasing downwards. The reason that is pressure at a point due to increases the height of the liquid column above it. So the thickness of the walls is increasing towards the bottom. So to withstand, the arrows in the figure show the increasing pressure towards the bottom of the dam. See arrows. Okay, now let's move on to the next part, that is the most important, or one of the most important in this chapter, that is atmospheric pressure. Like liquids, gases also exert pressure. Our earth is surrounded by air to a height of about 200 kilometers. So how much is the air column? It is 200 kilometer. This envelope of air around the earth is called atmosphere. Air has weight. Air also exerts a thrust on earth. The thrust on unit area of the earth's surface due to the column of air is called atmospheric pressure. So do you know how much force does this exert? It's about 2 lakh. It exerts 2 lakh, almost the force of 2 lakh newtons. Force is measured in newtons. But why don't we feel it on our heads when we are feeling this much force? Because do you know the heart pumps the blood in a great pressure. So what happens? Why don't we feel this 2 lakh Newton force on our head? Because you might have known about blood pressure, right? The blood is pumped in veins, in the blood vessels with a greater force than 2 lakh. It is slightly more than 2 lakh. So we don't feel the pressure. We have blood pressure. You have blood pressure monitoring machines, right? So that's why, because the blood pressure BP, which we say, is more than 2 lakh Newton. Okay, that's why we don't feel it. The weight of air exerts on a earth. Okay, the thrust on the unit area of the earth surface due to the column of air is called atmospheric pressure. This is about 10 to the power 5 Newton meters minus square. Thus the thrust. So thus it thrust of 1 lakh newtons acts on every meter square. Our body is about 2 meters square. So it will exert. So 1 meter square, it's exerting a pressure of 1 lakh or 100,000. So for 2 meters, it will exert 2 lakh Newton force. So that's why. Okay. So now they have given activity 9 and 10. I will explain 9. In the first, also in the previous video, I think I mentioned that that the atmospheric pressure is measured with a column of 76 centimeter of mercury column, mercury Hg column, mercury column. Or you can say how much 76 centimeter equals 760 millimeters of mercury column. We can say in both of these, but it's better to use 76. It's your wish. You can use any of these. So activity 9. Take a postcard and a glass. Okay, a glass filled with water. Glass filled with water. Take a card, postcard. They used to be thick, right? Then now You put this water, you put your hand over here, end over here, turn it upside down, upside down, upside down. What will happen? It will become like somewhat like this. The glass will be like this, exerting like this. So the water is exerting pressure downwards. Water is exerting pressure downwards. But the atmospheric pressure is opposite and exerting like this. So nothing happens. That's why nothing happens. The water stays like in the glass only, because both the pressures are almost equal. Standard value of atmospheric pressure. 10th one is also easy. It's almost the same. So standard value of atmospheric pressure. This I've told you. 76 centimeter here. This one. Now they also given that 1 atm 76 centimeter or 760 millimeter of mercury column, which is equal to 1 atm or 1.013 into 10 to the power 5 pascals. PA, Blaise Pascal. We have read this in the previous video. We have note the atmospheric pressure decreases within the increasing altitude. As we go higher above the air pressure decreases. So the higher we go, the air pressure decreases. Air pressure decreases. You might have seen astronauts going up. They wear special suits. You might have seen. Those are to withstand the decreasing pressure, air pressure. So here some examples in daily life to show the existence of atmospheric pressure. When a drink is sucked with a straw, the air of the straw goes into the lungs, thus the air pressure in the straw decreases. So I will show you this using a diagram. You have this. This is a drink. Water, you can say. You want to drink water using a straw. Straw is like this. I have twisted it somewhat, but it's like this. Then this is your, you can say this is your mouth, you can say. So what happens? Wait, I will show this again. It is not perfectly. Yeah. So this is the you can say mango juice which you want to drink. With this straw, you put it like this. This is your mouth. So what happens? The atmospheric pressure is downwards here. So when you drink this, the air goes into your lungs, and the atmospheric pressure helps in the pushing of the liquid downwards. So this has nowhere else to but go to the straw, into the straw. So this is why this is the can, you can say, or something else which you are drinking from. This is atmospheric pressure. Okay, atmospheric pressure. So you can say this is the atmospheric pressure, and this is why you can drink this juice. Okay, they have given many more. We have 10 examples. I will explain some of these. I've given the first one. When we blow air into a balloon, it bulges. It bulges, right? The balloon is like this first, then it will become more bulged because of the pressure exerted by the air filled on it. It is due to atmospheric pressure that ink gets filled into a fountain pen. Water is drawn by a well by using a water pump because of atmospheric pressure acting in the water of well. So well is like somewhat like this. Water is filled here, like this. Water is filled here. There is a pipeline. Is almost like the straw thing. There is like this. Pressure is exerted downwards. Atmospheric pressure. I'll written as it A. So when it is exerted downwards, they have no other way but to go into this pipeline, and through that we get these pumps, right? Water pumps, which we see. You might have seen these in villages. They have to apply force like this, and then the water will come up. Why? Because pressure is downwards. They have no way to escape except this pipe. They'll come out like this. Okay. So next one is astronauts and mountaineers have a nosebleed. They get a nosebleed because of decreasing in air pressure. I've told you, right? Increase in height, decrease in pressure. This is also an important point to remember. Increase in height, decrease in pressure. But what happens when there is decrease in height? It will be increase in pressure. When you go up below the sea level, you might have seen, because of high pressure, some submarine vessels, they get exploded because of that. This is nosebleed occurs often at high altitudes. The reason is atmospheric pressure is low at high altitudes, pressure pressure inside the human body does not change. That is to more than 2 lakh Newton. So what happens? Atmospheric pressure decreases than 2 lakh. Then we have nosebleed, but human body does not change. Thus, the exceeding excess pressure inside the body compared to the atmospheric pressure causes nose bleeding. The blood comes out of our nose, sometimes our ears also. Next, we have solved examples, the numericals. If you want, I can discuss this in the next class. We have discussed everything. Let's just recall what we have discussed in these 3 videos. Okay, I will just start from the beginning what we have discussed. Right, force definition we have discussed, examples we have discussed of force, both of size changing and the distance covered. We have discussed unit of force, SI unit is Newton. Distance covered, we have distance covered of is SI unit of distance covered, or area is meter square or meter. Next we have 1 kgf. How much is 1 kgf? 1 kgf, it's not the movie, it's the unit, kilogram force. Okay, it's 1 kgf is equal to 10 Newton. Nearly, this they have given it as nearly, means approximately. Its real value is 1 kgf is equal to 9.8 newtons. Okay, but we calculate using 10, I think. Next, effect of turning of force. This one is important. Pivot point we have written. So pivot point, we have discussed this example also. Have you tried this? I had door one. In the first video I mentioned this door. So next one, moment of force. I've given the definition also. Unit of moment of force. So that is nothing but Newton into meter. And the CGS system, you will get this sometimes. CGS is dyne. Dyne is for force, and for distance it is centimeter. We have discussed this example. Then we have discussed the pressure in the last class, effect of thrust, nail. Next is units of pressure, that is 1 Newton by 1 meter square. That also can be written as 1 Newton meter, like this. Okay, this is minus, or this is equal to 1 Pascal. Pascal is nothing but it is given in the honor of Blaise Pascal, the scientist. Next we have discussed this numerical, and we have discussed activity 1. 2 you can do it, it's easy also, same. We have discussed this boy standing on this. We have discussed increase in pressure, increase in area, these liquid pressure I have told you all. Then I have told you the 2 factors affecting the liquid pressure. This is also important. One is height column, and other one is density of the liquid. So sugar solution we have done this, same field, and height column we have done. I have shown you the dam also. The dam, what happens, the water is the wall is like this, the dam is like this. So this diagram is not coming very, I'll show you this is important, this one, dam one, I'll show you. So it's like this, and this downwards it's going. Then you have this like this here like this, it is somewhat like this. Or I've shown you this, the water pressure goes like this, it increases as we go downward, and here the wall is also increasing as we go downward, you can see. So this is this time the diagram is not proper. In the last class I've shown this. Atmospheric pressure we have discussed in this class only. We discussed activity 9. We have discussed some examples, and numericals are easy only, but if you want any of these you just tell me, okay? Or I will make another video for these numericals. Okay, thank you everyone. I will meet you in the next class with a new chapter. Thank you, bye.